bem-vindos a mais uma edição da Health Week, uma parceria entre a Faculdade Unimed e a For You EdTech. Nós, da Unimed, temos o propósito de levar saúde para que o maior número possível de pessoas possa viver mais e melhor. Para isso, a cooperação e o conhecimento são essenciais. É nessa convergência entre saúde e educação e o propósito de contribuir para o bem-estar e a qualidade de vida das pessoas que a Faculdade Unimed encontra a sua vocação. A realização dessa semana, com conteúdos qualificados e convidados de relevância nacional e internacional, é uma maneira de alcançarmos ainda mais profissionais de saúde e os públicos interessados no tema. A programação aborda a saúde em suas múltiplas dimensões. Cuidados com o corpo e a mente, frente aos avanços da neurociência, tecnologia e inovação, gestão e qualidade, educação e trabalho na área. Desejamos que você aproveite os conteúdos e se junte a nós nesse movimento por um sistema de saúde que seja cada vez mais efetivo, sustentável e inclusivo. Muito obrigado por se conectar conosco.
Sejam todos muito bem-vindos ao quarto dia dessa segunda edição da Health Week, o maior congresso de saúde da América Latina. Primeiramente, eu gostaria de parabenizar você que chegou até aqui e que tem acompanhado esse evento incrível feito pela Faculdade Unimed, essa instituição que é referência na capacitação de profissionais da saúde e grande incentivadora do crescimento desse setor. Por isso, como parte da sua missão, a Faculdade Unimed, durante todos os dias de Health Week, está sorteando bolsas de pós-graduação para todos que estão participando ativamente do Congresso. São, ao todo, 500 bolsas de 20%, 100 bolsas de 50% e 10 bolsas de 100%, sendo as bolsas integrais sorteadas 2 por dia. Portanto, se você ainda não ganhou a sua bolsa, ainda há grandes possibilidades de realizar essa conquista. Lembrando que, para concorrer, você tem que seguir os seguintes passos: fazer o check-in aqui na página, ao preencher o formulário disponível e permanecer no grupo oficial do Congresso no WhatsApp. Mas atenção, as bolsas de pós-graduação são limitadas e, se você ganhar, tem até 48 horas para realizar a sua matrícula. Assim que o prazo encerrar, a sua bolsa será destinada para outro participante. Portanto, fique atento. E além das 18 pós-graduações de diferentes áreas, a Faculdade Unimed também possui 3 pós-graduações de dupla titulação, com um certificado emitido por uma instituição de ensino parceira da Europa, 27 certificações profissionais com cursos de curta duração, que permite ao profissional se especializar nas mais diversas áreas da saúde, e 22 cursos ProHealth, que são cursos internacionais de curta duração, onde o aluno recebe um certificado tanto da Faculdade Unimed quanto da Alebat, a nossa parceira internacional. Outro grande incentivo da Faculdade Unimed que você conquistará com essa segunda edição do maior congresso de saúde da América Latina será um certificado de participação com o selo da instituição. Ele será apenas para aqueles que participaram de, no mínimo, 75% das palestras. Então, não esqueça de fazer o seu check-in. Sem mais delongas, minha gente, vamos dar início ao nosso quarto dia de Health Week, que terá como tema Mente e Neurociência. As presenças confirmadas de hoje são Lembke, que é chefe da Stanford Addictional Medicine, Judson Brewer, professor na Universidade de Brown, Daniel Kahneman, Nobel em Economia 2022, e Dr. Fábio Gastal, diretor acadêmico da Faculdade Unimed e presidente da ONA. Hoje será um dia repleto de referências internacionais na saúde, que irão compartilhar os seus conhecimentos e experiências com você. E quem irá abrir o dia de hoje será a doutora Lembke, que com a palestra O Poder da Mente, Desvendando a Neurociência por trás do comportamento humano. Vamos então dar as nossas boas-vindas à doutora Lembke nessa segunda edição da Health Week.
Hi, everybody. Welcome to Health Week. My name is Anna Lembke. I'm a professor of psychiatry and addiction medicine at Stanford University's School of Medicine, and also author of the book Dopamine Nation: Finding Balance in the Age of Indulgence. It has been translated into Portuguese, is available in Brazil, and I'm really excited to be here today to talk with you about some of the main messages in my book, Dopamine Nation. What I'd like to share with you today is the fundamental neuroscience of how we process pleasure and pain and what happens to our brains as we continually engage in that activity and in some cases ultimately progress to addiction. And I'd also like to suggest to you a hypothesis about what may be contributing to the mental health crisis that we're experiencing in the modern age. So let's go ahead and begin with the slides. This is a summary slide of what I'll be covering today, my primary learning objectives. First, I'm going to talk about the pleasure-pain balance, an extended metaphor for how we process pleasure and pain. Then I want to talk about the plenty paradox, which is to say the way that this primitive wiring for processing pleasure and pain is mismatched for our modern ecosystem, a world of overwhelming overabundance in which almost every human substance and activity has become drugified in some way. And then finally, I'm going to talk about what we can do about it, which can be briefly summarized as abstain, maintain, and seek out pain. And when I use that word pain, I'm using it both for things that are physically painful or difficult, but also for emotional, cognitive, and psychological challenges. And I'll qualify that further as we go along. So first, let's talk about the neuroscience of pleasure and pain. There have been a lot of very exciting advances in neuroscience in the past 100 years, and primary among those is our understanding of the brain's motivation and reward systems. Neuroscientists have identified a dedicated circuit in the brain for processing pleasure and pain. It's called the reward circuit. It broadly consists of the prefrontal cortex, which is that large gray matter area right behind our foreheads, and deeper midbrain structures like the nucleus accumbens and the ventral tegmental area. And when these structures are behaving in a healthy way and communicating in a positive and healthy way, then all is well in terms of our consumption. But as we'll see with addiction, there is either a miscommunication or a misfiring in this dopamine reward pathway, which contributes to the neurophysiology of the addictive compulsive behaviors that we associate with the disease of addiction. Broadly speaking, we can liken this circuit to a car, and we can liken addiction to either a problem with the brakes, as in not enough brakes, or a problem with the accelerator, as in too much accelerator, where the prefrontal cortex acts as the brakes, and the nucleus accumbens and ventral tegmental area, rich in dopamine-releasing neurons, acts like the accelerator. One of the most exciting findings in neuroscience in the past 75 years is the discovery of dopamine in the 1950s as a human brain neurotransmitter. Now, dopamine was understood to be an animal brain neurotransmitter long before this, but was really identified as a human brain neurotransmitter only in the 1950s. What do we mean by a neurotransmitter? Neurotransmitters are those chemicals that bridge the gap between synapses. So a synapse is that gap between neurons. Neurons are the essentially the wires or the cells that, like wires, that conduct electrical circuits that make us who we are. But those neurons do not touch end to end. They're separated by a little gap called the synapse. So there's an electrical signal that comes from the presynaptic neuron. It needs to get to the postsynaptic neuron, and chemical messengers called neurotransmitters bridge that gap. You can think of the presynaptic neuron as a pitcher in a baseball game, the dopamine as the ball that gets pitched, that binds to the postsynaptic receptor, which is the catcher's mitt, and then that postsynaptic neuron is the catcher itself. Okay. So dopamine has been discovered to be essential for the experience of pleasure, reward, and motivation. It is not the only neurotransmitter or chemical cascade involved in that process, but it is the final common pathway for all reinforcing drugs and behaviors. And broadly speaking, the more dopamine that's released in the reward pathway and the faster that it's released within these synapses, the more likely a substance or behavior is to be reinforcing and therefore to have the potential for addiction. This slide here summarizes a whole series of experiments done in rodents, rats, and mice, where a probe was stuck in their brain to measure dopamine firing in the reward circuitry in response to certain behaviors or the ingestion of certain chemicals. Now, keep in mind that we're always releasing dopamine at a baseline tonic level of firing. It's kind of like the heartbeat of the brain. So what we're looking for here, what we're looking for is differences outside of that baseline level, either above baseline or below baseline. And this graphic here is focusing on how dopamine firing increases differentially in response to different reinforcers. And what you'll see is that chocolate increases dopamine firing temporarily 55% above baseline. Sex is 100%, nicotine 150, cocaine 225, and amphetamine 1,000. That would imply that cocaine and amphetamine are much more reinforcing and potentially addictive than chocolate and sex in rats and mice. And that turns out to be true. So a rodent will press a lever for the delivery of a stimulant like cocaine or amphetamine, either to the point of exhaustion or until death. And one of the ways that neuroscientists measure how addictive something is in rats and mice is how hard they're willing to work for it. That is, how many times do they press that lever per unit time. One thing to keep in mind, though, is that these findings are a little bit artifactual in the sense that the way that amphetamine works is to directly release dopamine into the synapse. So you're going to get artificially elevated levels of dopamine in response to amphetamine that you won't see with sex, for example, because sex works through multiple chemical cascades like the serotonergic system, our endogenous opioid system. But the final common pathway for all of these reinforcing substances and behaviors is dopamine. And the key to keep in mind is that the more dopamine that's released in response to a stimulus and the faster that it's released, the more potentially addictive that stimulus is. One final point to make about this slide is that it doesn't address the concept of drug of choice. Drug of choice means that what may be really reinforcing for your reward pathway may not be as reinforcing for my reward pathway or vice versa, which is why usually when we see addiction, people will talk about their drug of choice. Either it's alcohol or it's stimulants or it's opioids. And there's a lot of polypharmacy where people use multiple substances, but folks can usually identify what their main substance is. Dopamine is a neurotransmitter that's also essential for the experience of movement. In fact, even the most primitive worm will release dopamine in response to food in the environment, and that dopamine allows them to locomote or move toward that substance. We also know that dopamine is the neurotransmitter that gets depleted in another part of the brain called the substantia nigra in Parkinson's disease. It's probably no coincidence that the same neurotransmitter that's involved in movement is involved in pleasure, reward, and motivation, because most organisms need to move and do work in order to get their reward. Of course, with humans, that's no longer true. We can swipe right or swipe left or click a button, scroll up, scroll down, and have our drug of choice delivered to our doorstep, which really complicates things for our brains. And I'll talk about that soon. Okay, another very, very exciting finding in neuroscience in the last 50 to 75 years is that pleasure and pain are co-located in the brain. So the same parts of the brain that process pleasure also process pain, and they work like opposite sides of a balance. Imagine that in your reward centers, there's a beam on a central fulcrum, kind of like a teeter-totter in a kid's playground. When we experience pleasure, it tips one way, and when we experience pain, it tips the opposite way. There are certain rules governing this balance, and the first and most important rule is that the balance wants to remain level, or what neuroscientists call homeostasis, which means that with any deviation from neutrality, our brains will work very hard to restore a level balance. And when we do that work of restoring homeostasis, it also kicks off our own adrenaline or cortisol stress response. So it's stressful to have to restore homeostasis. So how do our brains do that? Well, this is really the key to understanding what happens in the brain as we become addicted. The way that our brain does this is first by tilting an equal and opposite amount to whatever the initial stimulus is. Let me show you first here. Imagine that we engage in something that's reinforcing. We eat chocolate, go on social media, play a video game, look at porn, go shopping. That releases dopamine in our brain's reward pathway. The more dopamine that it releases and the faster that it releases, the harder and faster our balance tips to the side of pleasure. But no sooner has that happened than our brain adapts by downregulating dopamine transmission and production, not just to baseline, but below baseline. That's called neuroadaptation. I'd like to imagine that as these little gremlins hopping on the pain side of the balance to bring it level again. But the gremlins like it on the balance, so they don't get off as soon as it's level. They stay on until it's tilted an equal and opposite amount to the side of pain. This is the come down, the hangover, the Blue Monday, that moment of wanting one more piece of chocolate, watching one more TikTok video, reading one more chapter in a romance novel. It's called the opponent process mechanism. And it creates that state of craving such that if we had more of our drug available, we would want to ingest it immediately as a way to restore the balance and also potentially get back to the pleasure side. But in a world of scarcity and ever-present danger, which is the world in which humans have existed for most of the time that we've been on planet Earth, there aren't a whole lot of rewards. And we usually have to do a lot more work to find more rewards. Today, however, that's not true. Those rewards are instantly available, again, at the touch of a finger. And so we tend to ingest more and more and more of them. And what happens is that as we do that, those gremlins start to multiply and they get stronger and stronger. We end up with Arnold Schwarzenegger gremlins. And pretty soon we have enough gremlins to fill this whole room. And now we are entering the addicted brain. And in the addicted brain, we've effectively changed our hedonic or joy set point. Those gremlins are now camped out on the pain side of the balance. They've changed our threshold for experiencing pain and pleasure. Now we need more of our drug in larger quantities and more potent forms, not to get high, but just to level the balance and feel normal. And when we're not using, we're walking around with the balance tilted to the side of pain, like the one you see here, experiencing the universal symptoms of withdrawal from any addictive substance, which are anxiety, irritability, insomnia, depression, and craving. What is craving? It's a narrowing of our focus and attention on getting the drug, using the drug, hiding drug use, and starting the cycle all over again, as well as, in some cases, an intense physiologic struggle to get us to engage with that drug again. And this is exactly why people with severe addiction will relapse even days, weeks, and in some cases months after they've stopped using. Even when they can see objectively that their lives are better, their brains still aren't better. And that's what causes relapse. This is just another way of graphically representing the same thing. On the left-hand side, you can see how dopamine firing changes in response to a high reward stimulus over time. Dopamine levels spike upward and then go into free fall, not just baseline, but below baseline in equal and opposite amount. That's our opponent process reaction before going back down to baseline levels. So for every pleasure, we pay a price, and that price is conscious or unconscious pain and suffering, even if it's just manifested as the urge to do it one more time. But look what happens on the right side of the balance with repeated exposure to the same or similar reinforcing stimulus. That initial upward deflection to dopamine levels increasing gets weaker and shorter in duration, but that after response gets stronger and longer. So the pain side gets worse over time. And if we continue to press on that pleasure side of the balance, more and more gremlins accumulate on the pain side, we can end up in this chronic dopamine deficit state that I was just talking about. This is a very famous image from Nora Volkoff, who's the head of the National Institute of Drug Abuse in the United States, showing what happens in people's brains if they use highly addictive substances over time. Here, red represents healthy dopamine transmission. On the left-hand side, this is the brain of healthy control subjects. And you can see there's lots of red in their nucleus accumbens, part of their reward pathway. But on the right side, there's very little red. That's because these individuals who've been using addictive drugs are in a dopamine deficit state. And importantly, these images were taken 2 weeks after these individuals stopped using. So you can see that they're in a chronic dopamine deficit state. This really also explains why those first 10 to 14 days of stopping use, that early recovery phase, is so incredibly painful for people, and it feels like it will never end. And it's the big factor that often prevents people from stopping or makes them relapse. It's because they're in this dopamine deficit state and their brains are crying out for more drug. Okay, once those neuroadaptation gremlins have been created, even when they hop off the balance, they never entirely go away, right? They're now ready to go. If we see that, if our brains see that drug again, they're hopping right back on the pain side of the balance, plunging us into the depths of craving all over again, which is why people with severe addiction will relapse, in some cases, even after many years or decades of abstinence. This is a graphic representation of a series of experiments in rats and mice showing that dopamine levels will change not only in response to the drug itself, but even in response to reminders of the drug. So what you see here is a probe stuck into a rat's brain to measure dopamine levels. This line here tracks dopamine levels over time. This rat has been trained to know that when it sees a light, if it goes over and presses a button, it will receive an injection of cocaine. And of course, if you look at dopamine levels in response to the cocaine, they go way up. But I want to focus your attention on right here on when the rat sees the light. And what you'll see is that dopamine levels increase firing just a little bit when the rat sees the light. So just knowing our drug is coming, or anticipating our drug, or being reminded of our drug makes us a little bit high. But the key piece here is that dopamine levels don't go back down to baseline in response to that light. They actually go a little bit below baseline. So we enter a little mini dopamine deficit state in response to the reminder, which then creates the craving that makes it almost impossible not to go and get our drug of choice. If you think about notifications or alerts that we get on our phones, or reminders about streaks, or checking for, a treasure chest in a video game, all of these things basically set us up for craving by giving us a little bit of a dopamine bump followed by a little bit of a dopamine deficit, which then makes it really hard to resist the urge. What happens when we expect a certain reward and we don't get it? Well, that's shown here graphically, that this rat was trained to think, okay, I see the light, I press the button, I get the reward, but the reward didn't come. Dopamine levels go way below firing. So if we're struggling with addiction, when we go into that deep dopamine deficit state, what we feel is an intense drive to do even more work to get even more of our drug so that we can bring those levels back up again. The developing brain in children is a very vulnerable time. It's a time when our neuronal networks are very plastic, meaning that they're totipotent, that there are lots of different branches between those synapses that could go either way. And basically what happens through childhood and our teenage years is that our brains cut back or prune the neuronal synapses that we're not using and myelinate or make more efficient the neuronal synapses that we use most often. And in this graphic, red represents synapses or neurons. And you can see when we're 5 years old, we have more neurons and more synapses than we'll have the whole rest of our lives. And slowly through that childhood process, our brains prune back the ones we're not using. And by about age 25, we kind of come to the end of our intense neuroplasticity, and we have the scaffolding for our adult brains for the rest of our lives, which is why it's so important that we make sure that we insulate our kids from harmful behaviors and harmful substances so they can build up healthy adaptive coping strategies, including regarding digital drugs. Okay, now I want to widen the lens a little bit and talk about the plenty paradox. That's the way in which overabundance itself is a modern stressor caused by the mismatch between our primitive wiring and the modern dopamine-rich ecosystem. You might very reasonably ask, why on earth would Mother Nature build a system like the pleasure-pain balance in which we have to suffer after every time we have some kind of intense pleasure? That seems cruel, right? Why do that? Why not just let us get pleasure and then go back to baseline? Why make us go to that pain side before going back to baseline? And the answer is because this pleasure-pain balance is an awesome system in a world of scarcity and ever-present danger, which is the world that humans have evolved in over these many millions and millions of years. If we have a system that lets us just hang out on the pleasure side and not have to suffer after pleasure, well, we wouldn't be that motivated to work very hard to get more pleasure. But oh my goodness, a system that has us go right to pain right after pleasure, we would be extremely motivated to keep looking for the next source of reward. And of course, that's what has allowed us to survive these many millions of years. The problem is we now live in a world of overwhelming overabundance in which almost everything that we ingest, including food, our food supply, and almost everything we do has become drugified in some way that is made more reinforcing, more potent, releases more dopamine in our reward pathway, more accessible. Our smartphones essentially function as a kind of hypodermic syringe for digital drugs 24/7. More bountiful. We have more of our drugs than we ever have had before because of this amazing technology and supply chain that we have all over the world. And number 4, novelty. Not only are old drugs made new, but we have drugs that didn't exist before. Things like online pornography, social media, video games, online shopping, cryptocurrency, you name it. And the result is that we are constantly bombarding our reward pathway with dopamine from the moment we wake up and grab for our phones to our Netflix binges in the evening. And in order to compensate or to try to compensate, what we are doing individually and collectively is down-regulating dopamine transmission so that we're all in a dopamine deficit state. And I believe this explains in part why so many people are so unhappy and why the rates of depression, anxiety, and suicide are going up all over the world. If you look at happiness surveys in the last 20 years, people are less happy than they were 20 years ago in the richest nations of the world. So the very places that you would imagine people would be thriving are the very places where people are reporting less and less happiness. Likewise, with mental health issues, we know that anxiety and depression are going up fastest in the richest nations of the world, and going up faster than in poorer ones. This is in no small part attributable to also digital drugs, right? The smartphone came out in 2001. Digital media is a drug. It lights up the same part of the reward pathway as drugs and alcohol. We have potent forms of digital media like TikTok, very potent, very short. So a sudden spike in dopamine followed by dopamine free fall, setting up that craving to watch more and more videos. I know for me personally, once I start watching TikTok videos, it's very hard for me to pull myself out of it. That's because it's operating in this hedonic treadmill or this dopamine loop. Really astonishing that the average American spends 8 hours a day consuming digital media. So what can we do about it? Broadly speaking, we can abstain, maintain, and seek out pain. Let me talk about that. First of all, we recommend a dopamine fast. 20 years ago, if a young person came into my office and said, I'm anxious and I'm depressed, the first thing I would have done was either prescribe an antidepressant or recommend a certain type of psychotherapy. Now, the first thing that I do is I do a screening for digital consumption and consumption of other high dopamine rewards, cannabis, alcohol, other drugs, any kind of digital media, video games, pornography, shopping, YouTube, you name it. And if I discover that their consumption is high, I will recommend a dopamine fast for 4 weeks. And what I'll say to them is it's possible that by eliminating your consumption of this high reward substance for 4 weeks, you will be feeling better even without our having to do anything else. Why? Because by abstaining, we allow enough time for those neuroadaptation gremlins to hop off the pain side of the balance and for homeostasis to be restored. But I always warn people, you're going to feel worse before you feel better. In the first 10 to 14 days, when you take that weight off the pleasure side and abstain from your drug of choice, those gremlins are going to slam your pleasure pain balance down to the pain side, and you will experience the universal symptoms of withdrawal, which are anxiety, irritability, insomnia, dysphoria, and craving. But if you can just get through those first 10 to 14 days, you're going to come out of that tunnel on the other side feeling so much better. And in our clinical experience, and this is also supported by some clinical research, about 80% of folks who are depressed or anxious who engage in a dopamine fast end up feeling better after 4 weeks of abstinence, even without doing any other intervention. Sometimes patients will say, well, I don't want to give up my video games for my whole life. I can do it for 30 days. If I'm just going to go back to using, why can't I just decrease my use? And what I say to them is it turns out that what we see clinically is that decreasing to a lower amount from a higher amount is actually harder than quitting cold turkey, letting your brain rest for 4 weeks, and then going back to using a lower amount. So even if your long-term goal of your drug of choice, whether alcohol, video games, cannabis, pornography, whatever it is, if your goal is moderation, it's still best to do a dopamine fast or an abstinence trial. Let your brain reset reward pathways and then go back into using in moderation with a lot of detailed limits around what that will look like and how you will remain accountable. The maintenance part is the ways that we can put barriers between ourselves and our drug of choice so that we're not relying on willpower alone, but instead we're insulating ourselves from the constant triggers of our drug as well as the drug itself. So if we take digital drugs, for example, we can use space, time, and meaning as different categories of what I call self-binding, these barriers between ourselves and our drug of choice. Space refers to actual geographic barriers. So we can delete apps. We can power the phone down before putting it off. So actually turning it off. We can physically separate from our phone by leaving it home or leaving it in the office when we go out for a walk. We can create tech-free spaces like never bringing it in the bedroom. We can use time as a self-binding strategy. So digital intermittent fasting is a way of saying during these time periods, I will allow myself to be on my device, but not outside of those time periods. Looks like I just lost my slides, but that's okay. And then categorical has to do with the ways in which that we can, there it is. Our meaning has to do with how we can be intentional and try to use according to our values. One of the thought experiments I say to people is imagine if you would feel comfortable giving your phone or other device to a friend and giving them free access to look at where you've been on the internet. And if there are things that you wouldn't want them to see on there, then those are things that you consider you might want to change that behavior around. So just moving on, getting close to the end here. The final part of the advice is to intentionally seek out pain. I believe that in this age of overindulgence and in this dopamine overloaded world, we need to discover a new form of asceticism or intentionally seek out pain in order to live in balance. Because we were really wired for pain. We were wired for pain and minimal pleasure. And we live and now experience intense pleasure, and we're largely insulated from pain. If you remember those neuroadaptation gremlins, when we pressed on the pleasure side, they hopped on the pain side. Well, it turns out if we press on the pain side, they will go ahead and press on the pleasure side, and we can get our dopamine indirectly by paying for it up front. This is things like exercise, ice cold water immersion, fasting, meditation, prayer. The key here is that we want to make sure we use right-sized pain, so not too little and not too much. For example, we're not talking about cutting here, not self-cutting or other forms of self-harm. That's not good for us, right? That's too much pain too fast. But we're talking about things that press a little bit on that pain side to get those neuroadaptation gremlins to go on the pleasure side so that we can speed up resetting our dopamine reward pathways by getting our dopamine indirectly. This is a graphic representation of the same thing where you see that with exercise or meditation or ice cold water bath immersion, initially there's no dopamine firing, but over time dopamine levels gradually increase. This dashed line represents when we stop the exercise or the ice cold water or whatever the behavior is. But note that dopamine levels remain elevated for hours afterwards before going back down to the baseline position. This is your runner's high or your post ice cold water shower immersion high. And the nice thing is that when we do this, we never go into that dopamine deficit state because we paid for our dopamine up front. And this is really how we were wired. We were wired to work really, really hard to get a little bit of reward. Instead of how we're living now is we're not having to do any work at all to get a huge bolus of reward, which is not healthy for us. This is the science of hormesis. Hormesis is Greek for to set in motion. And it shows that by exposing our bodies to mild to moderate doses of toxic stimuli, we actually get our body to upregulate its own healing mechanisms. And these are just some examples that you might incorporate into your own life if you're not already doing that. Including doing domestic things that you maybe do anyway, but you might do them listening to something or watching something. And I encourage you to experiment with doing them unplugged, because by doing things unplugged, we're allowing our brains to rest, which can be really hard. And we can go into withdrawal and experience boredom, which is what I hear a lot. And dealing with boredom can be really scary, not just because it's boring, but because boredom can bring up deeper existential questions like, why am I here? And what am I doing? And why am I doing it? And why do I live? And why do I die? But I think those are important questions for us to engage with. But just know that it's painful. This is not an easy task. Just unplugging is hard in the modern age, but I encourage you to try it. In conclusion, this is an acronym, dopamine acronym that sort of sets up this framework that you can try on yourself or you can try with patients. D stands for data. That's where we get the facts. What are you using, how much and how often? And don't forget digital drugs, including things like online shopping. And you will discover how much and how often a person is using it. And be especially alert and attentive to daily use, because daily use is more likely to make these neuroadaptive brain changes that set us up for this addiction vortex where it feels voluntary, but it's not voluntary. O stands for objectives. This is where you ask them why they're doing that behavior, right? So everybody uses for a reason. In my book, Dopamine Nation, I talk about how I got addicted to romance novels. The Kindle was really the medium that sent me from recreational reading into addictive use. But my objective was to escape, right? To reward myself at the end of the day, to not have to think my own thoughts. Now, P stands for problems. In my case, the problems that I encountered where I was staying up some nights till 2 or 3 in the morning reading. I was tired at work, therefore I was less present for my patients. I would come home at night and be impatient with my kids and my husband. I took less joy in my job and in my family in the way that I used to. My focus got very narrowed on just escaping through fantasy. And pretty soon I was like reading books to work and, reading them in the 10 minutes between patients, getting more and more depressed over time. But the other big problem is the one we don't see, which is this process of neuroadaptation and the gremlins. I also needed more potent forms over time. So I went from like the Twilight Saga, which was my gateway drug, to all the way to reading 50 Shades of Grey, which is essentially socially sanctioned pornography for women, which is not consistent with my values, but nonetheless, I was very caught up in it. So it's important to get the sense of what problems our patients are experiencing, even if the only problem is that the drug's not working the way it used to, right? Like they're having to get more and more. Then you can talk to them through all of this about the gremlins. And then A stands for abstinence. That's where we ask them for an abstinence trial, 4 weeks, preferably, to reset reward pathways. We can tell them about hormesis and embracing a new kind of asceticism as a way to speed up the process of restoring healthy dopamine firing. M is mindfulness. Having to give up our drug of choice forces us to sit and just sort of feel our feelings, think our thoughts, and tolerate them as they pass over us. And also in some ways separate ourselves from them and realize we are not our thoughts. Insight is that aha moment when we realize, oh my gosh, I thought that, using cannabis every night was helping me sleep. But now that I've stopped for a month, I realized that it was actually creating the insomnia in the first place. So those kinds of aha moments are super important, because when people have them, then they're motivated to change their consumption. We don't have to persuade them anymore. And so then we help them after the dopamine fast create a plan for next steps. Okay, you're feeling so much better after dopamine fasting. What do you want to do? You want to continue to fast for another 30 days? You want to go back to using? Whatever they choose, we help them make a very specific plan. That's the next steps part. How much, how often, with whom, in what circumstances? What are you going to be red flags for relapse? How are you going to remain accountable? And then E is experiment, where we have them go out and try that plan, see how it works. And sometimes it works and sometimes it doesn't. I know for me, I gave up romance novels once I realized I was addicted. I realized it because I was talking with a student and we were role-playing motivational interviewing. And he said, is there a behavior you want to change? And I said, yeah, my late night reading. I spared him the details. But the next day I couldn't unsee it. And I was like, I really do want to change that behavior. Decided to give it up for a month as I counsel my patients to do. I went into florid withdrawal, especially insomnia. I had really lost the art of putting myself to sleep otherwise. But by weeks 3 or 4, I felt so much better. I was like, oh my gosh, I'm good. I'm going to go back to reading a novel this weekend. I binged the whole weekend, didn't sleep, went to work bleary-eyed on Monday and realized, wait a minute, I can't use this drug in moderation. I really need to stop it for the long haul, which I then did. So, it's this process of experimentation, give and take. Also want to add that if you have a patient who does the dopamine fast, comes back 4 weeks later and is still depressed and anxious or whatever their symptoms, that's also really useful information because it tells you, okay, I got to intervene in another way, that clearly this was not sufficient. Also want to say this is not an intervention that we would recommend for someone who had repeatedly tried to stop on their own and wasn't able to, right? We need a higher level of care. Maybe they need to go to residential rehab, or for someone who is at risk for life-threatening withdrawal, like from Xanax or from alcohol or from an opioid. Those people would need medically monitored detox. Nonetheless, I really hope that this has been a helpful framework for you, for your patients. As an experiment, if you cannot relate to the problem of addiction, you might consider your phone a drug and try to reset your tech life by going on a digital fast, which is even just 24 hours can sometimes be enough to tell us how much these digital drugs have taken over our brains. You can optimize your chance of success by setting a quit date, going cold turkey, letting people know how to reach you otherwise. Anticipate those symptoms of withdrawal. Know that you're going to feel worse before you feel better. Know that your brain is going to make up all kinds of stories for why you should really check your phone, even though you committed to not doing it. When you get intense cravings, try hormesis, right? Take a cold shower. Force yourself to do 20 sit-ups, go for a walk, do something hard, right? Read an encyclopedia, I don't know. And then when the fast is over, assuming you feel better, make a plan for how you want to either stay abstaining, or if you're going to go back to using, be very specific about when you're going to use, how much, and how often. All righty, I think that is the end of my slides. I hope this has been helpful to you. It's been a pleasure to talk with all of you today, and good luck, and may you find the balance.
Doutora, muito obrigada por essa palestra, que de verdade foi uma verdadeira aula. Entender como os níveis da dopamina influenciam no comportamento humano é realmente essencial para quem atua na área da saúde. Essa, sem dúvida alguma, foi mais uma das oportunidades que a Health Week pôde proporcionar. E se você tem interesse em neurociência e ficou com aquele gostinho de quero mais, instigado a se aprofundar nesse assunto, a Faculdade Unimed tem algumas pós-graduações que podem ser do seu interesse. Os cursos Cuidados Paliativos, Saúde Mental e Atenção Psicossocial e Nutrologia são apenas alguns dos nomes que me vêm à mente. Você pode conhecer todos os nossos cursos disponíveis logo abaixo, nessa mesma página em que você está assistindo o evento. E com o sorteio das bolsas de pós-graduações, um desses cursos pode ser a próxima adição ao seu currículo. Agora, para dar continuidade, vamos dar as boas-vindas ao psiquiatra, professor e responsável pelo Centro de Inovação e Pesquisa em Atenção Plena na Universidade de Brown. Além de possuir mais de 17 milhões de visualizações na sua palestra no TED, Judson Brewer, com a palestra Usando Mindfulness para aliviar a ansiedade e quebrar hábitos pouco saudáveis. Seja bem-vindo ao Health Week, Judson Brewer.
Hello, everyone. Welcome to Health Week. My name is Dr. Judson Brewer. I'm an addiction psychiatrist and a neuroscientist. And today I'd like to talk with you about how to use our brains to work with unhelpful habits, whether it's anxiety or stress eating or other things. A lot of things that many of us struggle with as we're going through our training and even as we start our careers in the public health and helping patients. So I will just start with some disclosures. I will be talking today about some of the digital therapeutics that my lab has developed in collaboration with a company called ShareCare. All of these conflicts of interest are managed by Brown University, where I'm a professor and also work at the Butler Hospital, our psychiatric hospital. The other thing I'm required to mention is that I've written a number of several books related to habit change and mindfulness. The most recent one's called Unwinding Anxiety, and I get royalties from that. Thought I would start with a story of a patient that I started seeing about 4 years ago. This patient was referred to me for anxiety, and when he came to my office, I could see that he was pretty anxious. That was pretty clear. It turns out he was about 40 years of age, and he'd had anxiety, pretty severe anxiety, for about 30 years of his life. He met all of the criteria for generalized anxiety disorder, and he also met criteria for panic disorder. I'm showing a picture here of somebody driving on the highway because he was getting panic attacks driving on the highway, which had led him to avoid driving on the highway altogether. In fact, he was pretty anxious just driving on local roads. The other thing that I noticed from his first interview was that he was very overweight. He was about 400 pounds. So how would I help somebody with severe anxiety and who is at a very unhealthy weight? I show you this cartoon that says, "I see, and have you tried worrying about it?" Because that's what I was doing when I saw people with anxiety. The best medications that are out there that I can prescribe, about 1 in 5 people show a significant reduction in symptoms. The term is called number needed to treat, and that number is 5.2. So I was basically playing the anxiety lottery and playing the medication lottery because I didn't know which of the next 5 patients was going to benefit from medication treatment and what to do with the other 4. Now, helping my patients with anxiety was not only a struggle that I was having professionally, but I also started getting panic attacks during residency when I was in training to become a physician myself. So I will talk later in the program about how I worked with my own anxiety, but let's keep going with this patient now. So medications can help about 1 in 5 patients. What do I do with the other 4? Well, how about my patient's obesity? You know, in medical school, I learned the formula calories in versus calories out, which is basically saying if you make sure that you eat fewer calories than you burn off, then you'll lose weight. That formula is still correct today. Yet despite knowing this information, as you can see from this interactive graph, in the United States, the obesity rates are only increasing. They're not getting better despite knowing this information for a long, long time. So what are we missing, and how can we use this information to not only help our patients, but also help ourselves unwind unhealthy habits. I'll start with this quote from Albert Einstein. He says, "No problem can be solved from the same level of consciousness that created it." And what he's pointing to is that there's a part of our brain called the prefrontal cortex. It is the youngest and the weakest part of our brain from an evolutionary perspective. So if we try to think our way out of anxiety or think our way out of overeating, we're not going to be very successful. As this youngest and weakest part of the brain, the prefrontal cortex, ironically, is the first part of the brain that goes offline when we're anxious or when we're stressed, which can lead us to just worrying more or stress eating more or doing other unhealthy habits. So what can we do? What can we learn about our own brains? And instead of fighting against our brains, learn to leverage our brains to work for us. That's what we'll talk more about today. How can we learn how our brain works? And how can we learn to make our brain work for us? In one slide, this is a very simplified version of how our brain works. But basically, you can think heuristically. This isn't really how our brain works, but from a functional standpoint, we have these survival brains that are really set to help us survive and set up habits that way. And then we've got this younger part of the brain that's involved in thinking and planning. Now, if we can't rely on the new parts of our brain, how can we actually learn how the old parts of our brain work and learn to put them to work for us? Well, the way that the old parts of the brain work are through a process called reward-based learning. This process is evolutionarily conserved all the way back to the sea slug. So humans and sea slugs learn in a similar way. And basically, this is set up to help us remember where food is and to also remember where danger is so we can avoid it in the future. The process, many of you may have heard of it, is called positive and negative reinforcement. And it goes like this. There are three key elements: a trigger, a behavior, and a result. So, for example, if our ancient ancestors were foraging for food, they needed to remember where it was so they could go and find it the next day. So if they're foraging around, they see some food, there's the trigger, they eat that food, there's the behavior. Then their stomach sends this dopamine signal to their brain that says, remember what you ate and where you found it. That's the reward from a neuroscience standpoint. That's how we learn any habit: trigger, behavior, reward. Well, how well does this process work in modern day? It works extremely well. In fact, there are lots of industries that capitalize on this process to get us addicted to unhealthy behaviors. For example, and this is just I love this slide because the Doritos is a purely manufactured object. I'm not even sure it fits into the category of food. But you can see how there was an expose article in the New York Times from 10 years ago now that suggested that the food industry actually literally hires engineers to design food to be addictive. This is not limited to food, this process of, seeing things, getting us addicted to them, and then getting us to eat more of them. This is also true for social media and other behaviors as well. Each tweet, each click, each like is designed to get us coming back for more. So what this suggests is that there's actually a whole lot known about how our brain works. So why aren't we leveraging what we know to help us unwind unhealthy habits, to help us work with things like anxiety, to help us work with things like burnout and so on? Well, my lab's been studying a process called mindfulness training for a couple of decades. And it turns out that mindfulness training may be something that can help us learn to work with our brains. Just to put a simple definition out there around what mindfulness is, Jon Kabat-Zinn, who pioneered the mindfulness-based stress reduction program back in the 1970s, suggests that mindfulness is paying attention in the present moment, on purpose, and non-judgmentally. From a neuroscience standpoint, I like to think of how does this actually work in a mechanistic setting. So if we look at positive and negative reinforcement, and I'm using smoking and eating as examples, what we're often taught to do is to avoid cues that trigger us to do unhealthy behaviors, or provide substitution behaviors, such as, instead of smoking a cigarette, just eat some candy instead. The problem is that neither of these actually dismantle the core addictive habit loop. So it stays intact. The idea with mindfulness is that it drives this wedge of awareness in, so that instead of habitually acting on that urge to smoke or eat or to worry, we can bring a pause in, bring some awareness in, and learn to step out of the process itself. Here's an example from a patient that I saw in my clinic. He came to me to quit smoking, and he'd been smoking about 40 years. And so we calculated the number of times he had reinforced this habit loop. Are you ready for this? He had reinforced it roughly 293,000 times without knowing that it was a habit loop itself. He didn't know how his brain worked. So the first thing I do with patients like this, or with anybody learning to unwind an unhealthy habit, is to have them pay attention to the habit itself. That's what mindfulness is all about. So it might seem strange. Well, how does paying attention actually help us break unhealthy habits? Well, here's an example of somebody using our smoking program. We have them pay attention as they smoked, which seems kind of paradoxical because we tell ourselves to not smoke. Well, I say, go ahead and smoke when somebody comes to my clinic and tries to quit, but I have them pay attention as they do. This person reported what I typically see. Somebody said, oh, I was paying attention, mindful smoking, smells like stinky cheese and tastes like chemicals. Yuck. Now, what this is highlighting is this reinforcement learning process. Reward-based learning is called reward-based learning for a reason. The reason for that is if something's rewarding, we're going to keep doing it. If it's not rewarding, we're going to stop. So that paying attention process is the first step in stepping out of the process. In a few minutes, I'll talk about this 3-step process, but I just wanted to give you a taste for how this works. Or as Yogi Berra put it, you can observe a lot just by watching. I won't go into the details, but in our first study of smoking cessation at my lab, we actually got 5 times the quit rates of gold standard treatment in helping people quit smoking, simply by having them bring these mindfulness training processes to bear. So when we started to see that mindfulness training could be helpful, we asked this question, well, how do people typically learn a habit? Well, they don't learn it in my office. So can I actually package my office and bring it to them? So about 10 years ago, we started developing apps, now called digital therapeutics, to help people unwind some of these unhealthy habits. We started with a program for smoking called Craving to Quit, then went on to develop a program for eating, helping people unwind eating habits, and then even one for anxiety. All of these based around these unhelpful positive and negative reinforcement habit loops. Now, you might be wondering, how is anxiety a habit? I was wondering the same thing. In fact, I never learned in medical school or residency that anxiety could be driven like a habit. All I learned was that I should prescribe X, Y, or Z medication and hope that it worked. Well, it turns out that back in the 1980s, Thomas Borkovic suggested that anxiety could be driven through negative reinforcement, as you can see here. That unpleasant feeling of anxiety drives the mental behavior of worrying. Yes, worrying can be a behavior itself. And that feeling of avoidance or feeling like we're in control or at least doing something is enough to drive this habit process forward. So we developed this unwinding anxiety program and did a study. And the first study we did was with anxious physicians. Why? Because we figured that anxious physicians would be really challenging population to work with. We physicians tend not to take care of ourselves very much. So if we could start with folks that were struggling, that we could, were really challenging to work with, we figured we might be able to work with anybody. So in this study, we started by just checking to see if there were correlations between anxiety and burnout in physicians. This had not actually been done before. So we looked at the Generalized Anxiety Disorder 7, the standard clinical measure of anxiety, and also the Maslow Burnout Inventory, and just checked to see if there were correlations. And in fact, with the two main components of burnout, emotional exhaustion and callousness, we saw very strong correlations. So we gave these anxious physicians who tend not to have time to do much or do much self-care, we gave them this unwinding anxiety app and just said, 10 minutes a day, see if you can learn how your mind works. So we'd give them these short modules that helped train them to see how their mind worked. We would use animations and other things to help drive key points home. And then we would give them in the moment exercises to help them work with these worry habit loops in the moment. We could also embed things like experience sampling. So as a researcher, I could see how well these programs actually worked. You ready for this? In our first study with anxious physicians, we got a 57% reduction in anxiety at our primary endpoint, which was 3 months. Now you can see this is a relatively small study, but it was enough to tell us, okay, there's something here to study more. We then looked at reductions in burnout, even though we didn't mention burnout in the program. But if you remember, the two are correlated. And in fact, as people reduce their anxiety, they also reduce their levels of cynicism. So this was the callousness score. You can see it dropping by 50%. We also saw a reduction in emotional exhaustion, but there was a smaller percentage change. It was about 20%. And even though it was statistically significant, this made a lot of sense. You can work with individual factors contributing to burnout, such as callousness, with an app, but you can't change institutional factors like being overworked with an app itself. And so we could see differential effects there. Well, we went on to do a randomized controlled trial of this unwinding anxiety app in people with generalized anxiety disorder. Remember, my patient who had generalized anxiety disorder was really struggling. Well, in folks like him, we saw a 67% reduction in anxiety when we just simply added this app to general treatment. And in fact, we got a 64% remission rate, which was pretty remarkable. Now, if you remember at the beginning, I mentioned the number needed to treat for medications is 5.2. In this study, that number was only 1.6. The smaller the number, the better, meaning you have to treat fewer people to see a significant reduction in symptoms. So this was really encouraging. It suggested that we could not only treat things like smoking cessation with mindfulness training, but even problems like anxiety. How about eating? I won't go into all the details just in the interest of time, but we've also studied the Eat Right Now app, and we could see a 40% reduction in craving-related eating and a 35% reduction in eating to cope with negative emotions. This was a study led by Ashley Mason at UCSF. So bringing all of these data together, what this suggests is that if we actually pay attention to how the brain works, we can actually develop programs, evidence-based programs that deliver mindfulness training to help people work with their brains themselves. So how does this actually work? I'll talk for a few minutes about some of the neuroscience behind how mindfulness changes brains. And then we'll go through this 3-step process that any of us can use. Let's start with what I think of as the caught up continuum. When we get caught up in daydreaming, it's pretty easy to snap out of it if somebody says, hey, pay attention. It's a little harder when we're caught up in stress. It'd be great if somebody could just say, hey, stop being stressed. We might even get more stressed when somebody tells us to relax. And on the far end of the spectrum, when we're caught up in addiction, we might even be aware of it, but feel like we're totally out of control. So we can get caught up in behaviors ranging from daydreaming to addiction. And in fact, this is pretty common. Even with daydreaming, one study suggested that about 47% of waking life most of us are caught up in daydreaming. So if this happens very commonly, we can actually study what this looks like in the brain. And there are a lot of studies now suggesting that getting caught up in our experience activates a network of self-referential brain regions called the default mode network. Don't worry about the details here, but I'll just show you how some examples of what happens. And we're going to focus in on these two yellow parts, the posterior cingulate cortex and the medial prefrontal cortex. These are the two hubs of the default mode network, as you can see from this network analysis. There was a study published a couple of years ago that just showed adolescents their own Instagram feeds and gave some of the pictures a bunch of likes and some just a few likes. What these researchers found was that this activates the reward centers of the brain, like the nucleus accumbens, but also activates these self-referential brain regions. For example, the posterior cingulate, as you can see in circled here in red. So there's something rewarding about getting a bunch of likes. There's something rewarding about thinking about ourselves, basically. This also gets activated when people who are addicted to cocaine are shown pictures of people smoking crack cocaine. It lights up like a Christmas tree in people who are addicted to cigarettes, who are shown pictures of people smoking. You can see the same trend with pathological gambling and even with eating chocolate. And this study is interesting because at both ends of the spectrum, when you feed people chocolate and they're really excited for that next piece, their posterior cingulate gets activated. And if you keep feeding and feeding and feeding and feeding them until they absolutely don't want any more chocolate, they also activate their posterior cingulate cortex, both ends of the spectrum. What this suggests is that getting caught up in wanting more and getting caught up in wanting less both activate this process of getting caught up activates the posterior cingulate cortex. This also happens the more people worry. So it's not just addiction. It's not just getting a bunch of likes on Instagram. It's also when we worry about the future or when we regret things that have happened in the past. Now, why am I showing you all of this work related to the default mode network? Well, mindfulness training may be something that we can use to work with this process itself. The training is set up to help us get out of our own way, not get caught up in thinking about ourselves, in worrying about the future, in getting caught up in a craving. Over 10 years ago now, my lab started studying experienced meditators to see what their brains looked like when they were meditating. And we found something really interesting and unexpected. Here's an image of composite brain images of experienced versus novice meditators. And here, blue means deactivation. So across the entire brain, we looked across the entire brain. Across the entire brain, these two hubs of the default mode network are the most deactivated in experienced meditators relative to novice meditators. And we looked across 3 different types of meditation to find this. So what this suggests is that, in fact, experienced meditators are not getting caught up in their experience when they're meditating as compared to novice meditators. We could then go on and do prospective studies in people who haven't been training to be experienced meditators, where we can, for example, bring in people that want to quit smoking, and we can run them through this smoking paradigm. This was led This is a paradigm developed by Amy Janes, who was first at Harvard and now at the National Institutes of Health. In collaboration with her, we could bring people in, show them pictures of people smoking, show them neutral stimuli, and contrast those two to see how active their default mode network gets. Then we could randomize them to get our mindfulness training program versus the National Cancer Institute's Quit Guide. A month later, we can scan their brains again to see if changes in brain activity predicted outcomes. And here you can see that there's a pretty strong correlation between reductions in cigarette smoking and reductions in brain activity. Yet this is specific to mindfulness training. You can see there are no correlations in the active control group. And in fact, there's a dose-dependent response. The more they go through the program, the better they do. Again, no correlation in the control group. So what this suggests is that we're actually targeting specific brain networks with mindfulness training, these networks that are activated when we get caught up in our experience. So what is actually happening when we're getting caught up in our experience? We went on to do some studies where we could give people feedback from their own brains in real time as they're meditating to see what their brains look like, so we can correlate their subjective experience with their brain activity. And we were fortunate enough to have Anderson Cooper from CBS's 60 Minutes come in and try this out on camera. We can do this with feedback with fMRI. We can also do this with source estimated EEG. And this is what his brain looked like.
This is just the next generation of exercise. We've got the physical, exercise components down, and now it's about working out how can we actually train our minds.
Dr. Brewer is trying to understand how mindfulness can alter the functioning of the brain. He uses a cap lined with 128 electrodes.
We're going to start filling each of these 128 wells with conduction gel.
The electrodes are able to pick up signals from the posterior cingulate, part of a brain network linked to memory and emotion.
This is all just picking up electrical signal from the top of your head.
Since attending the mindfulness retreat, I'd been meditating daily and was curious to see if it had an impact on my brain.
We're going to have you start with thinking of something that was very anxiety-provoking for you.
Okay. When I thought about something stressful, the cells in my brain's posterior cingulate immediately started firing, shown by the red lines that went off the chart on the computer screen.
Just drop into meditation.
Okay. When I let go of those stressful thoughts and refocused on my breath, within seconds, the brain cells that had been firing quieted down, shown by the blue lines on the computer.
That's really fascinating to see like that.
Dr. Brewer believes everyone can train their brains to reach that blue mindfulness zone, but he says all the technology we're surrounded by makes it difficult.
So how can we train our brains? What we've found over the last number of years is that there seems to be a three-step process of habit change. I go into detail about this in my book, Unwinding Anxiety, but we can go through this pretty quickly here now, and any of us can start to put this into practice. So I'll outline the 3 steps, and then I'll go through each of the steps one by one. The first step is becoming aware of being caught up in a habit loop. The second step is exploring the results of the behavior, asking simple questions like, what do I get from this? And the third step is learning to step out of these habit loops. So how does this work? I'll show some examples from people that have actually gone through our programs to highlight each step. So the first step is to recognize that we're in a habit loop. If we can't recognize it, we're going to be on autopilot. That's what habits are all about, is doing things without paying attention. So we have people map out this 3-step process, or these 3 elements of a habit loop. What's the trigger? What's the behavior? And what's the result? Here's an example from somebody using our Eat Right Now app. They said, I understand why I go to food, to avoid or cover up or distract from uncomfortable feelings such as anger, sadness, or restlessness. Who wants to feel those things? Trigger, uncomfortable feeling. Behavior, eat something that temporarily diminishes the feeling. Reward, still have to deal with the unpleasant feelings plus the sugar headache. I can clearly see how I got caught in this habit loop trying to escape difficult feelings with food, but that ultimately it doesn't work. So you can see this first step is pretty simple. What's the trigger? What's the behavior? What's the result? In fact, we can make it even simpler. We don't have to worry about the trigger because it's that behavior and the result relationship that drives future habits. So we can really zoom in on the behavior and what the result of the behavior is. What do I mean by this? Well, this is where step 2 comes in. And I think of this as the beginning of the end because we can't go back. So there's a part of the brain called the orbitofrontal cortex that is involved in determining how rewarding a behavior is. So for example, if I eat some broccoli and I eat some milk chocolate, my brain compares those two. And of course, from a caloric standpoint, milk chocolate packs in more calories. So our brains typically will prefer chocolate to broccoli. Then if I eat some dark chocolate, it's going to compare those. And for me, dark chocolate is much more rewarding than milk chocolate. Now, this process has been worked out pretty well these standard reinforcement learning models have been around for about 40 years now. For example, back in the 1970s, Rescorla and Wagner developed this model, which is relatively simple, and it highlights the key to behavior change. The key to behavior change isn't willpower, it's actually awareness. And what I mean by this is, if you look at the formula, there's an error term that determines whether we're going to keep doing the behavior or stop doing it. And that breaks into two categories. Typically, if we do something and it's really rewarding, we get what's called a positive prediction error. We hadn't expected it to be that good, but it was better than we expected. So we get this dopamine firing that says, hey, remember this, do it again. For example, if I go to a new bakery and I eat their cake and it's the best cake I've ever had, I get a positive prediction error and I learn, oh, this is a good bakery. On the other hand, if I go to that bakery and it's not very good cake, I get what's called a negative prediction error, where my brain says, don't bother coming back here again. So the key to behavior change is all about awareness. We can even measure this. We can embed awareness tools in our programs like the Eat Right Now program, and we can measure how quickly reward value drops and how that correlates with changes in behavior. So for example, we did a study with people using the Eat Right Now program who were overeating. We had them pay attention as they overate. And what did we find? Within 10 to 15 times of somebody overeating, that reward value drops below 0. And you can see that they start to shift their behavior. This was a relatively small study, so we followed it up with a larger community sample, and we found the same thing. You pay attention. What do you notice? Overeating doesn't feel very good. When it doesn't feel very good, we get this negative prediction error, and our brain says, this isn't so great, and we become disenchanted. It makes it much easier to stop doing that behavior in the future. Here's an example. Somebody said, dear sneaky habit loop that says eating junk food is fun. I am on to you, right? We see the same thing. Or here's another example. Somebody says, a shift is happening. I'm choosing more healthy foods. The sugary things are less attractive. Satiety is now coming into focus, right? So we can see how rewarding it is to not get a sugar rush and crash. We can see how rewarding it is to not overeat and therefore start to step out of that process. I won't belabor this point, but we see the same thing happening when people pay attention as they smoke. That reward value drops below 0 and they shift their behavior. Or as this person put it, today all the cigarettes I smoked were disgusting. So once we become disenchanted with these old habits, step 1, seeing what the habit is. Step 2, asking simple questions like, what am I getting from this? Feeling into our direct experience and seeing that overeating or smoking or whatever the unhealthy habit is, isn't very rewarding. That helps us become disenchanted. Then we can learn to step out of those old habit loops. And I think of this as finding rewards that are more rewarding. So as we've talked about, just using negative emotions as an example, we do all sorts of things to make unpleasant things go away. That's what negative reinforcement's all about. Well, instead of eating or worrying or smoking a cigarette or checking our social media or whatever, what if we substituted a different behavior, one that is intrinsically rewarding? That is, we don't have to look outside of ourselves to find the reward. Here we go back to Einstein, who says, I have no special talents. I am only passionately curious. So if we substitute curiosity for craving in this equation, we can do a couple of things. One is we can compare, what does curiosity feel like versus what does a craving feel like? Well, to our brains, it's a no-brainer. Curiosity feels better. I think of this as finding the bigger, better offer. If our brains are set up to form reward hierarchies and they're always looking for something more rewarding, let's find something that's intrinsically rewarding, like curiosity. Curiosity feels better than craving. Curiosity feels better than worrying. So when we're anxious, we can get curious. Oh, what does that anxiety feel like? Here's an example. Somebody said, when I first started the program, I didn't quite buy into the benefits of curiosity. Today, I felt a wave of panic And instead of immediate dread or fear, my automatic response was, that's interesting. That's like curiosity. That took the wind right out of its sails. I wasn't just saying it was interesting. I actually felt it. I was so thrilled. I'll give you one more example and then we'll finish up. This person said, I'm trying to listen to my body, stopping eating when my body has had enough to eat rather than finishing what's on the plate. That in itself is a bigger, better offer. So just bringing all of this together, what this suggests, what these ancient learning systems are pointing out is that it's helpful to be able to survive. Yet in modern day, when all of these programs have been engineered to get us to move into anti-survival mode, whether eating too much, worrying, going on social media, etc., these are actually not very good, survival. They lead to everyday addictions. What these data suggest is that curiosity can be substituted for these behaviors, and that this learning process can be repurposed, and we can get really good results simply by learning to awaken our natural capacity to be curious. As an example, I was learning mindfulness training when I started having panic attacks, and I started bringing that curious awareness to those panic attacks. And I would note, wake up in the middle of the night with a full-on panic attack, and I would note, heart racing. Feel like I'm going to die. I feel like I can't breathe. All of these things from a panic attack. And I would bring that noting in, and I would leverage what's called the observer effect. By observing our thoughts and our emotions and body sensations, we're not as identified with them. We can observe them, watch them come and go, and not feel like, oh no, there's something wrong with me. And that's exactly what I was able to do when I would have panic attacks. And importantly, it helped me not develop full-on panic disorder, where I would start worrying, oh no, I'm going to get another panic attack. Because I knew each time panic came, I could work with it. How about my patient that I mentioned who came to my clinic who had panic disorder, generalized anxiety disorder, and a lot of health problems related to his obesity. He had obstructive sleep apnea. He had steatohepatitis. He had a fatty liver, and he had hypertension. Well, when he came to my first clinic visit, we mapped out his habit loops. And the first one we mapped out was around panic with regard to driving. And I said, okay, go home, start mapping out your own habit loops, all of these related to anxiety. I sent him home with our Unwinding Anxiety app. And he came back 2 weeks later for his first follow-up. The first thing he said to me was, hey, doc, I lost 14 pounds. And I was a little startled because we hadn't even talked about weight loss at that first visit yet. But he said, I was mapping out anxiety habit loops. Anxiety was triggering me to eat fast food, which then I realized was actually making my health worse. And I was getting health anxiety, and this was just feeding it. So I stopped doing it. He went on to lose over 100 pounds and has maintained those gains over the last 3 to 4 years. He said it was the easiest weight loss he ever had, simply paying attention to what he was getting from eating fast food. He also found that eating healthy food felt much better for his body, didn't lead him to want to eat more, and also was helping his health issues. His sleep apnea went away, his hypertension normalized to normal blood pressure, and his fatty liver resolved. All of that with changing his eating habits and losing that unhealthy amount of weight. How did he do with his anxiety? About 6 months into treatment, I was walking out of our School of Public Health one day, which is on a busy street. Car pulls up, guy rolls down his window. It's my patient. I'm thinking, great, he's driving. He gives me a big smile and says, hey, doc, I'm headed to the airport. I'm an Uber driver now. So he went from panicking on the highway to becoming an Uber driver. All of that from learning how his mind worked and learning how to work with his mind and put it to work for him. So what this would suggest is that we all can do this. I'll just end with a quote that kind of highlights this process. This person said, what's most interesting to me is how we define the rewards. In the past, the reward of eating right has been weight loss. but it was more often than not short-lived because I hadn't made real process changes in my daily life. Here it feels like the reward is defined differently, and weight loss is a side effect. The reward here is, for a lack of a better expression, a more balanced life or inner peace. So I will end there. I just want to thank all of the folks that contributed to this research and our funders, mostly the National Institutes of Health. And if you would like to learn more about these processes, we have a bunch of free videos and blog posts, etc., that talk about this. We even have a free CME course for healthcare providers that can learn, that's devoted to helping people work with burnout and related issues. So you can just find that on my website. But if you remember nothing else, just remember this three-step process, or as Mary Oliver puts it, pay attention, be astonished, bring that curiosity in, and then share that with others. So thank you very much for your attention. And I hope this three-step process is helpful for you in helping work with any of your unhealthy habits, but also developing those really healthy habits that help you interact with others and connect with others, such as curiosity and kindness. Thank you.
Os nossos agradecimentos ao Dr. Judson Brewer por compartilhar todo esse conhecimento com a gente. Em nome da Faculdade Unimed, eu gostaria de agradecer a sua presença aqui hoje e complementar ainda mais para o crescimento de todos que estão nos acompanhando. E, claro, eu gostaria também de agradecer à própria Faculdade Unimed por proporcionar um congresso de tanta importância como esse, que está proporcionando crescimento e oportunidades. Já quero aproveitar para lembrar que, ao final da Health Week, serão distribuídos certificados de participação a todos que acompanharam a 75% do congresso. Continue fazendo o seu check-in aqui na página, completando o formulário e permanecendo no grupo oficial do WhatsApp. E agora, para complementar ainda mais esse quarto dia do maior congresso de saúde da América Latina, eu quero passar a palavra para o próximo palestrante, psicólogo, Nobel em Economia 2002, escritor do best-seller Rápido e Devagar, considerado o pai das finanças comportamentais, Daniel Kahneman.
Well, Mr. Kahneman, I think we're about to ready to start. Let me start and have you ask you first a general question about you have a very long career in psychology. You of course, graduation in 54, your PhD is 61 in Berkeley. And if we work with several people alongside the way, when did you ever consider the possibility of a Nobel Prize in economics for that body of work?
No, certainly not. Not early. You know, when our work was embraced by some economists, and so toward the end, before it happened, I knew that it was a possibility, yes. But when we started the work, certainly not.
Well, because at the end of the day, I mean, most economists were using a different model. They were not using the same kind of ideas that you propose.
Well, certainly. I mean, you know, that's why I got the prize. And it's because I wasn't doing the same thing as everybody else. The Nobel Prize is not given because the work is very good. It's not on the quality of the work. The Nobel Prize is given if the work is influential.
That's right.
And our work became fairly influential. You know, we published in 1979, and over the following 20 years, many people took it up, including important people. And that's why it happened.
I see. And that's there's one thing. In Brazil, we have most of the medical professionals. They don't have a very good financial education, and we see a lot of bad financial decisions. We see happens over time and again. A lot of people losing a lot of money on things like Ponzi schemes, cryptocurrencies, that kind of thing. Why do you think that continues to happen even with very well-educated people otherwise?
That happens when people are greedy. When people want to get rich quickly, then they do things that are not safe and that are not sound. So there is a solution to how to act in finance when it works for people who work for a living, are not dependent on achieving greater financial success. And then if you act conservatively, you don't need to be very clever. If you take risks, there you need to be very clever. And many people take risks and are not clever. That happens a lot. And so when you ask, I had never thought of it that way, but you're asking me about financial education, and you mean financial education for people who intend to take financial decisions on their own.
That's right.
Yeah. I mean, the conservative advice of behavioral economists would be, don't do it. So that's all the wisdom. Just don't do it, because you probably do not know what you're doing. So that would be the best advice. The other advice is really, it's not so much a matter of education, I think. Education is important, but it's a matter of getting good advice.
I see.
Yeah, and it's here, there are people who have experience in the market, especially they have experience with schemes or ideas about getting rich quickly, and they will warn you against them. But in general, if anybody tells you that they have a way for you to get rich quickly, you should know that it's probably not true.
That's probably the best advice.
Yeah, and that's very simple. It's hard to call it education. This is common sense, and for people, for getting rich quickly in the financial world is not something that can be done safely. So if you want to be safe, don't do it. If you want to take risks, get advice, and get advice from more than one person. And certainly don't get advice from people who will benefit if you get money. That's the first part of wisdom. It's sort of obvious. You don't need to be very sophisticated for that.
I see. There's one interesting thing about about the applications of your ideas and the systems that the meta models that you have created. Do you think they apply only for financial decisions? Do you think that they could apply to other areas of?
No, I mean, there's nothing. There is, in general, theories of this kind. There is a theory, and it applies very narrowly, and it applies to very specific situations. And then there are ideas from the theory, and those ideas, they travel better. But, but sometimes they help and sometimes they don't. So in our main idea, I think, we had two main ideas. One of them is not even terribly original. One is that people have a particular attitude to rare events, and that they exaggerate the possibilities of rare events. And the other one is that, that's three really. The other one is that people do not do the rational thing, and the rational thing is to think in terms of your overall situation. But people think in terms of gains and losses. And that gets them into trouble, because when you think of gain and losses, and you put more importance on losses, which people do, then you do not maximize your results. So thinking in terms of gains and losses is the natural way to do it, but it will get you into trouble if you do it all the time, because it is a very myopic way. It is a short-term way of looking at things. When you look at a project, at a prospect, and you think, I can gain that much or I can lose that much, that's one thing. But if you look at life, at the future, there will be many projects. And what you want to have, and that's really the wisdom of decision-making, when there will be repeated decisions of the same kind, then you want to have a policy about those decisions, and you don't want to pay too much attention to the gains and losses of any particular decision. You have to hold on to your policy. That's the advice that comes out of behavioral economics, is don't think small. Don't think about the particular problem. Don't take risks that could ruin you. Play with smaller gambles and repeated gambles. And if the expected value of the gambles is positive, eventually you'll do well. That's the advice.
Nice. Yes. In terms of, and there's this other, particularly in your book, in Thinking Fast and Slow, you propose that system 1 and system 2, the system 1 fast, intuitive, system 2 is slow and deliberate. Do you think that applies, for example, let me try to stretch a little bit. Do you think that applies to the daily practice of health professionals in some way, or does it apply to your daily activities in more general terms?
Well, certainly. I mean, most of what people do in the course of a day is well-practiced behavior, habitual behavior. They don't have to think about it much. This is system 1 at work. So the occasions on which you have to apply system 2, they are not, that's not what happens all day long. Most of the day are system 1 and, system 2 sort of looks at it and monitors, but it doesn't do a lot of hard work. When you have important decisions, big decisions, when you have to reflect, when you have to make an unusual decision rather than something completely routine, then system 2 gets involved.
I see. In another way, do you think that, particularly thinking about this application of the ideas of behavioral economics to other parts, do you think that we could apply to day-to-day daily decisions about your own personal health, for example? We were talking about, do you think, should I eat this or not, that kind of thing? That makes sense?
The problem of healthy behavior, as the way that behavioral economists look at it, is a problem mostly of self-control. So it's a very different problem than decision decisions. And the issue of how you behave, of how you achieve self-control with the minimum of work and with the best chances of succeeding, that is one of the main domains of behavioral economics.
And so at the end of the day, it's a matter of having this consistency over time, you could say, in that decision making.
Here there is another idea. And the idea is try to make good behavior easy. And what I mean by that is the best way to control yourself is by controlling your environment, by having an environment that has fewer temptations, by having an environment that is supportive of good behavior. So people have a chance to design their own environment and to design a healthy framework for their life. So going regularly to the gym, shopping for food, not shopping for food when you're hungry, but shopping for food, that is an opportunity to buy healthy food. And anything impulsive that you do is likely to be a problem.
So we try to avoid those opportunities.
So you try to create a world in which there are few temptations, and then you generally get tougher behavior. It's not good for people who are already obese. They're not going to lose much weight that way. There are drugs now that would do better than behavioral economics, but in general, the advice that behavioral economists have is that, if at all possible, change the environment, not the person. Give people a better environment in which it is easy to do what they want to do. If it is difficult, they won't do it.
Right.
But if it is easy, if you make it easy for them, there is a chance.
You said you're talking about how the Nobel Prize is awarded for works that are influential, and there's no doubt that behavioral economics has been very, very influential. But otherwise, the behavior of people hasn't changed all that much. I mean, people should be more aware of those biases and decision making, but that doesn't. Looking at the world, you think we keep on falling in the same traps.
Yes, and that's not a surprise. I wrote a book, Thinking Fast and Slow, and I made it very clear that it would not change anybody. And as the reason, and I said that, I think, in the book, that it didn't change me. So, I've been studying this kind of thing for, I don't know, more than 50 years, 60 years. And it doesn't, I act like everybody else. So the hope for major improvements in the quality of thinking is not in changing the behavior of individuals. It is in changing the behavior of organizations. So organizations have a chance to create an environment and to create procedures that facilitate good judgment and good decision making. For individuals, it's much more difficult.
If you let the decision at the hand of the individual, it's going to bound to be.
I think, on rare occasion, there are mistakes that I avoid. And because I recognize, this is a situation in which I'm likely to make that mistake. But this would be true when it's not particularly important and I'm not in a very emotional state. But if it's important and I'm emotional about it, I'm less likely to recognize mistakes, and so more likely to behave like everyone else, and knowledge doesn't have all that much influence.
Do you think those ideas, they apply across the spectrum? Do children behave in the same way as adults making the decision make? Is that something intrinsically human?
So different cultures think differently and make judgments differently. What I think is pretty general is that everybody has a system one. One is. And the development of thinking slowly and deliberating slowly, there are large differences in culture. And the kind of decisions that people make is very different across cultures because the incentives are very different in different cultures. What is considered honor and what is considered good behavior is really not the same across cultures. So there are large differences.
So you think that there would be advantages on thinking about the institutions, the education institution, to modify their environment to kind of like improve those.
Well, it's not so much the educational institutions. I think education is important because if the education is good, it teaches you something about slowing down. And slowing down is perhaps the best advice that there is. Just slow down. And if possible, slow down overnight. And if possible, get advice. I mean, there are some basic things that people can maybe learn to do so that they don't make big mistakes. So if you think you might make a big mistake, slow down. That's the education part. The education part, in general, makes people more reflective and makes them more open to advice. But when I was speaking of modifying institutions, I meant institutions like firms, like companies, that make decisions. And institutions can adopt procedures that will make better decisions because they think slowly. So institutions work slowly by their very nature. That gives them an opportunity to make people think in a particular way. Education is not sufficient for that.
Em nome de todos que estão aqui acompanhando a Health Week, eu gostaria de agradecer imensamente ao senhor Daniel Kahneman pela palestra incrível que a gente acabou de assistir. A Faculdade Unimed se preocupa com o futuro das organizações de saúde, com a qualidade dos atendimentos oferecidos, e um dos objetivos da Health Week é poder proporcionar as ferramentas certas para aqueles que atuam diretamente nesse setor e inspirar as mudanças necessárias para a sua melhoria constante. E a partir de mais de 18 pós-graduações em diferentes áreas, sendo 3 delas com dupla titulação, ou seja, você conclui uma pós-graduação e ganha 2 certificados, um da Faculdade Unimed e outro de uma instituição de ensino da Espanha, parceira da faculdade. Além das pós-graduações, a faculdade também oferece dezenas de cursos de curta duração, que são as certificações profissionais, entre elas nutrologia, telemedicina, inteligência emocional, LGPD para a saúde e diversos outros. Bom, agora vamos para o último momento do 4º dia de Health Week, para um bate-papo sobre mente e neurociência. Eu gostaria de convidar para se juntar a mim, aqui ao palco, o diretor acadêmico da Faculdade Unimed, superintendente de Informação, Inovação e Novos Negócios na Seguros Unimed, presidente do Conselho da ONA, médico e psiquiatra, Dr. Fábio Gastal. Chegou a hora de mais um bate-papo aqui na nossa Health Week. Dessa vez eu convido para conversar com a gente o Dr. Fábio Gastal, ele que é médico psiquiatra, diretor acadêmico da Faculdade Unimed e vai conversar um pouquinho com a gente sobre a mente e a neurociência. Doutor, muito obrigada pela presença, pela disponibilidade em conversar conosco nessa noite.
Muito obrigado pelo convite, pela oportunidade de estar aqui com vocês e de alguma maneira poder contribuir para um tema que é tão importante para a nossa sociedade.
Tenho certeza que vai contribuir bastante, até porque a gente já separou uma série de questionamentos. E a primeira pergunta que eu faço, doutor, é, na sua opinião, como a neurociência ela pode ajudar a promover a saúde mental e o bem-estar emocional na nossa sociedade nos dias de hoje?
É importante entender que desde o século XIX, o próprio Freud, quando escreveu os seus trabalhos, ele dizia que o dia que o muro da biologia caísse, a ciência ia compreender o psiquismo humano. Então, o que a gente está vendo agora, nesse momento da nossa história, é que o muro da biologia está caindo, ou seja, a gente está conseguindo realmente entender determinados mecanismos que integram fundamentalmente os aspectos propriamente biológicos da neurologia e da neurofisiologia com os aspectos do comportamento humano e da maneira como as pessoas reagem. E também com os aspectos ligados à genética que provoca essas especificidades dos seres humanos. Então, esse momento é um momento muito interessante, porque além de tudo isso, para complicar um pouco mais, nós estamos também falando da questão digital, né? Porque o cérebro humano ele não deixa de ser um computador extremamente poderoso, com uma série de capacidades de integração e de movimentos que de alguma maneira reproduzem o que a gente tenta reproduzir no computador, e com isso faz com que a gente consiga responder às questões que a gente vem respondendo ao longo da nossa história, né? Então, nesse momento, o que a gente está conseguindo cientificamente é compreender esses mecanismos muito delicados, muito finos, que não se entendia, que antes de alguma maneira se buscavam algumas explicações. No passado mais longínquo isso era explicado pela possessão demoníaca, pela fé, pela religião, e que agora, felizmente, está sendo entendido por mecanismos que, de alguma maneira, explicam os comportamentos das pessoas, né?
E a era digital, ela interfere muito na nossa sociedade, no comportamento das pessoas como um todo.
Com certeza, até porque, na verdade, nós estamos vivendo um momento que a gente chama em ciência do momento biodigital, ou seja, nós estamos num momento em que está se integrando toda essa questão da neurociência, da genômica, da genética, com a competência computacional para poder compreender, e aí vem essa questão do Big Data, da inteligência artificial e todas essas coisas que estão deixando todo mundo muito preocupado, como o chat GPT e essas outras coisas que não é o tema de hoje, mas a gente vai tentar conversar sobre algumas coisas.
São muitas as complexidades, muitos os avanços, e por isso mesmo que eu já emendo a pergunta e quero saber um pouquinho da sua percepção com relação às limitações e os desafios, né, atuais da neurociência diante de tudo isso que a gente está vivendo hoje em sociedade.
O primeiro grande desafio é que se conhece muito, mas se conhece pouco. Na verdade, ainda não se sabe de todas essas interações para poder dizer, bom, isso é assim por causa disso ou por causa daquilo. Isso é a primeira questão importante. As cadeias de causalidade, que a gente chama em ciência, elas não estão totalmente esclarecidas.
Não
então,
é matemático.
Nós estamos mais perto. E a gente tem que tomar muito cuidado, porque nós, seres humanos, a gente tenta sempre achar para um problema complexo uma resposta simples. E normalmente ela está errada. Então, ou seja, essa lógica do eletricista, ela não funciona em neurociência. Então tem que tomar muito cuidado com isso. Outro aspecto também é que nós temos grandes desafios éticos, porque na medida em que a gente avança na compreensão desses mecanismos que de alguma maneira se expressam no comportamento humano, nós temos que ser mais responsáveis eticamente nas nossas decisões, porque eventualmente nós vamos estar tomando decisões, por exemplo, de interferir no genoma, de tal maneira que esse genoma se expresse de uma forma mais saudável, mas nós vamos também poder estar selecionando quem a gente quer que se desenvolva, quem não, e aí a gente entra naquele livro do Aldous Huxley, que fala do C, dos B, dos A, que de alguma maneira tu cria humanos que são diferentes entre si por causa da genética e por causa do comportamento, e isso é muito grave.
E
isso
quando,
eticamente...
na verdade, o objetivo era ser saudável, ou seja... Né?
E aí o problema é esse, tu faz pessoas fisicamente saudáveis, mas com limitações que de alguma maneira interferem na maneira como a pessoa percebe a vida, percebe o amor, percebe a vida de relação, percebe a família, e isso pode ser muito grave também.
E de uma forma que não necessariamente vai ser natural.
Que é a mesma discussão que está se dando agora nessa questão da inteligência artificial, até onde a gente pode ir com a inteligência artificial. Porque, de certa maneira, a inteligência artificial, como ela foi desenvolvida a partir desse modelo da lógica difusa, que é a lógica mais próxima que se tem computacional do cérebro humano, ela de alguma maneira reproduz essas questões que colocam esses desafios, ou seja, até onde a gente pode deixar o computador ser capaz de aprender, de evoluir, de decidir, de tomar decisões por nós. Isso tem toda uma polêmica que está sendo criada, e é importante a polêmica, porque a polêmica vai nos permitir tomar melhores decisões, né? Então a gente tem que ser muito cuidadoso nesse momento, mas por outro lado não deve também adotar atitudes que é melhor deixar tudo, não deixar avançar, não deixar fazer pesquisa, não deixar os desenvolvimentos acontecerem. Eu acho que a pior coisa que pode acontecer num ramo da ciência é justamente tentar interferir artificialmente bloqueando o desenvolvimento, né? A gente já no passado tentou caçar bruxa, prender gente, cientistas, e que isso não levou a lugar nenhum e terminou que o processo continuou. Então, o importante é discutir abertamente, claramente, democraticamente, quais são os melhores caminhos que a gente pode seguir, entendendo que isso é irreversível, ou seja, nós vamos caminhar numa direção em que vai nos permitir entender melhor o comportamento humano, porque, na verdade, quando a gente fala de neurociência, a gente está falando fundamentalmente dos mecanismos íntimos, neurofisiológicos e bioquímicos cerebrais que se expressam em atitudes, em comportamentos, em relações, em maneiras de funcionar, que depois isso agregado em grupos, isso faz a sociedade.
A linha tênue está aí, talvez esteja na questão de até onde eu posso ir sem perder a mão. Né?
Exato.
É basicamente isso. E como, na opinião do senhor, a neurociência pode contribuir, de fato, para a educação e também no desenvolvimento humano?
Olha,
a gente estava falando do ChatGPT, por exemplo. A discussão do momento é os alunos usando o ChatGPT para fazer as provas.
E vai ter que ser assim. Vão ter que usar. Achar que a gente vai bloquear o uso não vai levar a lugar nenhum. Nós, como docentes e professores, vamos ter que aprender a melhor forma de ensinar utilizando esses recursos. Não é proibindo as crianças de usarem. É que nem nós querer proibir as crianças de usar o celular. É uma coisa que ela é contra-evolutiva e contra-intuitiva. Então isso termina gerando muito mais problemas de relacionamento do que realmente contribuindo. Então, uma das coisas importantes nessa questão da educação e do desenvolvimento é justamente compreender que é um processo muito complexo, muito sofisticado, e que a gente precisa fazer com que as escolas e as instituições educacionais elas tentem acompanhar a velocidade com que o conhecimento está se descortinando. Então, nesse aspecto é que é o grande desafio para as instituições educacionais e para o desenvolvimento, que é justamente como tu prepara a escola, o docente, o ambiente acadêmico para essas questões que são, digamos assim, da fronteira do conhecimento e que está disponível para uma criança brincar. Isso é uma coisa muito interessante e é uma coisa que não existia no passado. Né? Então,
talvez tentar explicar para essa criança que aquilo tem benefícios e também malefícios. Talvez, sim, se usar da forma errada, como tudo nessa vida, pode, sim, fazer mal, né? Sim. Agora, o senhor tem uma grande experiência em tecnologia de gestão e qualidade também em saúde. Como você vê a integração entre a neurociência e as práticas de gestão e saúde?
Aí, voltando um pouco ao que eu comentei, né? As práticas de gestão, elas são, de certa forma, a expressão comportamental altamente sofisticada do que nós somos neurofisiologicamente. Então, à medida que a gente seja capaz de compreender determinadas expressões comportamentais e, de alguma maneira, poder criar ambientes que sejam mais inclusivos, que de alguma maneira permitam que as pessoas expressem melhor sua maneira de viver e de entender as coisas, nós poderemos contribuir para que as instituições sejam mais saudáveis. E, consequentemente, se tu tem uma instituição mais saudável, porque às vezes, vou usar um exemplo prático para colocar, às vezes tu tem um mito daquele administrador autoritário, que é o cara que faz acontecer, que é lá meio machão, parará.
Todo mundo tem medo.
Que isso é um estereótipo e que, teoricamente, muito no mundo da empresa, isso parece que esse é o cara que faz gerar resultado corporativo, o que é um grande equívoco. Mas o problema é que a gente também não sabe o quanto responder a esses comportamentos, porque isso é um comportamento desviante. Isso é um comportamento que, de alguma maneira, não agrega valor e que, teoricamente, ele está sendo prestigiado pela sociedade, porque, no fundo, é uma sociedade autoritária, que tem toda uma história de autoritarismo e que valoriza esses comportamentos como ativos sociais. Se nós formos capazes, e aí sim entra essa discussão da moderna neurociência, o que é um comportamento que contribui para o desenvolvimento da humanidade? O que é um comportamento que agrega valor no longo prazo? Será que esse comportamento porque o vovô fez assim, a mamãe fez assim, o papai fez assim, eu vou fazer igual? Isso não tem muito sentido, ou tem. Aí é que a gente precisa entender o que realmente precisa ser compreendido para construir um processo evolutivo. Eu acho que a sociedade ela vai evoluindo meio que aos trombulhões, né? Ela vai bate aqui, bate lá e vai
vivendo, né? A gente
talvez
não sabe
através
exatamente pra
desses conhecimentos que envolve tecnologia da informação, envolve neurociência, envolve genética, envolve uma série de coisas que de alguma maneira a gente chama também de neurociência, isso termine contribuindo para que se tenha um caminho menos sofrido de aprendizado como sociedade, ou seja, a sociedade possa escolher seus caminhos sem tanta violência, sem tanta guerra, sem tantas desvios e sem tanta agressividade.
A gente pode aprender com os erros do outro?
Teoricamente, a gente sempre diz que pode aprender com os erros dos outros, mas a gente não aprende, né? Na prática.
Tem a escolha, né?
Mas
Podemos
talvez essa evolução permita essas discussões.
Eu queria falar um pouquinho mais sobre como o uso de métodos quantitativos e a epidemiologia na saúde e na saúde mental também tem ajudado a avançar a neurociência. Queria te ouvir sobre isso.
Isso é uma questão importante, porque no século XX, né, principalmente a partir dos anos 50, 60, depois da Segunda Guerra Mundial, a psiquiatria ela desenvolveu um ramo que a gente chama de psicometria, que trabalha muito essa questão da possibilidade de tu criar mecanismos de avaliação que permitam perceber determinadas doenças ou determinadas manifestações da personalidade a partir de questionários, inclusive, que de alguma maneira tu vai fazendo uma entrevista, que é o que praticamente o psiquiatra e o psicólogo fazem no seu consultório quando estão avaliando um paciente, que é uma entrevista não estruturada, mas que a gente foi desenvolvendo para fins de estudos das doenças em população, a gente foi desenvolvendo esses questionários, que inclusive nos anos 90, aí, já com o advento do CID-10, a Organização Mundial da Saúde, que eu tive a oportunidade de participar, desenvolveu a entrevista composta para diagnóstico psiquiátrico, que já gerava, a partir do algoritmo das perguntas que o paciente ia dando, ela terminava gerando uma hipótese diagnóstica, que complementava a hipótese do psiquiatra. Então, isso eu estou explicando uma aplicação, mas mostra um pouco essa questão da epidemiologia psiquiátrica. E aí, tu tendo a possibilidade de definir claramente quais são os sintomas da doença, quais são as características, tu consegue desenvolver melhor os medicamentos e os tratamentos que vão, de alguma maneira, fazer frente a essas manifestações, esses sintomas. E isso colaborou tremendamente para a evolução da psicofarmacologia. Então, hoje, por exemplo, a psiquiatria é uma especialidade médica tipicamente ambulatorial. Praticamente hoje não se interna mais pessoas por doenças psiquiátricas. É raro isso. No passado era muito comum, né? Então, por quê? Porque não se tinha esse conhecimento. Com a epidemiologia psiquiátrica e essas ferramentas que foram se organizando para investigar a saúde e a doença mental, se conseguiu evoluir e contribuir decisivamente para desenvolver intervenções realmente eficazes para promover a saúde e, consequentemente, minimizar os sintomas e a doença. Então, por isso a epidemiologia é importante e tem dado certo, né?
Uau! E, na sua perspectiva, como essas inovações recentes no campo da neurociência podem afetar a gestão e o planejamento de serviços na saúde? A gente estava falando um pouquinho sobre isso, né? Você poderia compartilhar algum exemplo de desenvolvimento, inovação ou transformação digital na área de saúde mental que considera particularmente significativo?
Eu acho que essa tua pergunta é muito interessante, porque ela conecta. Uma coisa é esse conhecimento que eu estava explicando do conhecimento clínico, né, que permite desenvolver um medicamento, desenvolver um tratamento, mas tem a outra questão importante, que é será que a gente é capaz de usar esse conhecimento também para melhorar as nossas instituições? E aí eu vou mostrar para você o paralelo que a gente teve, ou seja, nós já tínhamos os recursos terapêuticos, os medicamentos, mas os nossos hospitais continuavam sendo as mesmas drogas que vinham, drogas no sentido de mal gerenciados, mal operacionalizados, com políticas de saúde atrasadas, que levaram praticamente 40, 50 anos atrás do recurso terapêutico que existia. Então, ou seja, a política social, muitas vezes, ela é ela é atrasada em relação à política tecnológica, à capacidade de melhorar as condições de vida da população. Então, muitas vezes, o que acontece, vou pegar outro exemplo, nós temos hoje as vacinas, os tratamentos, mas nós continuamos tendo problemas de saúde que poderiam estar sendo resolvidos se a gente tivesse melhor organização do sistema de saúde, melhor gestão do recurso financeiro. E aí é uma coisa que passa por esse comportamento mais sofisticado, que é o comportamento da política, que é o comportamento em sociedade, que é o comportamento antropológico, que é o comportamento sociológico. Então, ou seja, às vezes a gente tem a tecnologia, mas não tem o comportamento que faz com que a gente consiga fazer com que essa tecnologia seja realmente eficaz.
Falta a humanidade ali, o toque, a forma de usar isso.
E isso talvez seja o grande desafio, né? Que é como fazer com que esses conhecimentos todos que a gente está construindo, eles não se percam no sentido de perder a humanidade e perder o humanismo. Porque eu acho que esse é o dado essencial. Nós temos muita tecnologia, nós temos praticamente toda a tecnologia necessária para não ter mais fome no mundo, para não ter mais grande parte das doenças que ainda a gente tem, para não ter mais pobreza e para não ter fome. E a gente continua tendo fome, pobreza, doença, tudo isso a gente continua tendo.
Porque talvez nos falte um pouco de humanidade para gerir todas as tecnologias e todos os recursos que nós temos a nosso favor.
E aí nós estamos falando de gestão, ou seja, o que nos falta é o comportamento social e o compromisso social necessário para a gente querer realmente resolver os problemas da nossa sociedade numa visão mais generosa, mais ampla, sem essa visão egoísta que eu resolvo o meu problema e tá aí, o resto não é problema meu. E com isso, então aí são essas questões que eu digo, é o fino do comportamento humano, é a coisa mais sofisticada e mais difícil de mudar.
É o querer, né?
Exatamente.
Interessantíssimo. E você poderia comentar também um pouquinho sobre a importância da pós-graduação e da formação contínua para os profissionais que trabalham na interseção entre a saúde mental e a neurociência?
Na verdade, assim, esse é um grande desafio, né? Porque hoje, se nós olharmos, nós temos uma oferta de profissão, porque para ser um profissional de neurociência, tu tem que fazer no mínimo uma graduação na área de biologia ou na medicina, nós estamos falando aí de 4 a 6 anos no mínimo de formação de graduação, mais pós-graduação, nós estamos falando de um profissional que leva de 12 a 16 anos para ser formado, para contribuir. Então, ou seja, se nós não investirmos decididamente na educação no Brasil, e que começa pela educação básica, nós não vamos ter esses profissionais. E justiça seja feita, o Brasil hoje é um país, é interessante, as áreas de maior impacto na medicina da ciência brasileira, uma delas é a psiquiatria e a saúde mental. Ou seja, o Brasil é um país que tem um bom... Só que o problema é o seguinte, manter esses profissionais na universidade, na pesquisa, nos serviços de saúde, hoje a gente está perdendo cérebros. O pessoal está indo embora do Brasil porque não tem condições de fazer pesquisa e continuar. Precisa de investimento. Então, ou seja, o grande desafio é nós transformarmos, e não é só neurociência e saúde mental e psiquiatria, mas é o que a gente quer para o futuro do nosso país. Porque se a gente quer um futuro para o nosso país, nós necessariamente vamos ter que discutir essa questão do investimento em educação, em capacitação, e por isso que a gente está fazendo esse trabalho hoje no caso do Sistema Unimed, que é justamente pensando não só na questão assistencial, de cuidar das pessoas, mas também na faculdade, na educação, na capacitação e transformando, de certa forma, conectando o nosso sistema com a questão educacional.
Um trabalho integrado.
Exatamente.
Não é isso? E tendo em vista as bolsas de cursos de pós-graduação, que foram concedidas nesse evento, inclusive, que tipo de conhecimento e habilidades você recomendaria que fossem foco para aqueles interessados em se aprofundar no estudo da mente e também da neurociência?
Olha, eu acho que tem, no mínimo, 3 conhecimentos obrigatórios. Genética, né? A questão específica de estudar, fazer uma boa formação na área de psiquiatria, psicologia, psicopatologia, todo esse componente da formação psi. E o terceiro, a questão da ciência da informação, da tecnologia da informação e da comunicação, da TI. Porque, na
Olha.
verdade, o futuro é a integração desses elementos no que a gente está chamando do biodigital. Só que no caso do biodigital, a parte psi é o biopsi-digital, porque, na verdade, envolve também o comportamento humano.
Ou
né?
seja, quem tem interesse já anotou aí, né? Os 3
bom
pilares
estudar,
importantes.
é bom estudar.
Bom, coisa para estudar não falta, né?
Sim, verdade.
Chegou ao
verdade.
fim a nossa entrevista. Muito obrigada, doutor Fábio.
Muito obrigado.
Foi um prazer. Obrigada
Obrigado.
por compartilhar o seu conhecimento.
Muito bom, muito
Foi
obrigado,
ótimo.
foi um prazer.
Conversamos, portanto, com o doutor Fábio Gastal, ele que é médico psiquiatra, diretor acadêmico da Faculdade Unimed. Doutor Fábio, muito obrigada pela sua presença aqui na Health Week, por contribuir ainda mais para o nosso crescimento, de todos, né, que têm acompanhado o evento, e por mostrar como a neurociência está conectada à educação e ao nosso desenvolvimento. Bom, a gente chegou ao fim do nosso 4º dia de Health Week, o maior congresso de saúde da América Latina. Tivemos a presença de importantes nomes hoje, o que, claro, vai ficar marcado para sempre na trajetória de quem busca estar sempre atualizado e em constante crescimento. E falando em crescimento, vamos agora para a divulgação dos ganhadores de hoje das 2 bolsas integrais para cursar uma pós-graduação na Faculdade Unimed. Os ganhadores são Aline Almerinda Macedo Ramos, de Santa Maria, Rio Grande do Sul, e Caroline Harton Faria de Barros, de Goiatuba, Goiás. Parabéns às ganhadoras, eu tenho certeza de que essa bolsa de 100% será mais um passo na sua evolução como profissional de saúde. Os ganhadores das bolsas de 50% e 20% logo serão contatados pela equipe da Faculdade Unimed, pelo WhatsApp, e-mail ou SMS, assim que o evento acabar. E lembre-se, os ganhadores têm 48 horas para realizar a sua matrícula antes que a bolsa expire. Assim que o prazo acabar, a bolsa será transferida para outro participante. Então, fique ligado nos seus canais que foram cadastrados para participar da Health Week. Finalizamos o nosso dia de congresso, mas ainda temos muito para compartilhar com você. Amanhã, a Health Week abordará o tema Educação e Trabalho na área da saúde. E a partir das 19h, esses serão os nomes esperando por você. Ana Escobar, pediatra, livre docente e comunicadora. Marcos Pianger, palestrante e escritor do best-seller Papai é Pop, apresentador e especialista em inovação, criatividade e novas tecnologias. Rafael Areses Gomes, vice-presidente sênior de desenvolvimento internacional da Inspira, e Dr. Elton Freitas, presidente da Seguros Unimed, presidente da Fundação Unimed e diretor-geral da Faculdade Unimed. Com nomes como esse, o seu certificado de participação na 2ª edição da Health Week possui ainda mais peso. Portanto, continue a fazer o seu check-in e permaneça no grupo oficial do WhatsApp. E agora, para encerrar, eu gostaria de deixar um questionamento para você pensar. Se você ganhar uma das bolsas da pós-graduação, você já sabe que curso você faria, que curso iria escolher? Muito obrigada por ter permanecido até aqui e nos vemos amanhã. Um grande abraço para você.